ESP 8266 and ESP32 system-on-chips can work as the Wi-Fi communication modules for other microcontrollers. To use them as a modem, the module must be flashed with the appropriate AT-command firmware. Espressif and other developers prepared the ready-to-use firmware with the AT-command interpreter. This firmware can be downloaded from the web and flashed into ESP8266 or ESP32 memory with a flash tool. While recording this video, the newest version of AT-command firmware, which supports the MQTT commands, is available for ESP32 chips only. ESP8266 doesn't have enough resources for this firmware.
Flash and test AT interpreter firmware for your ESP8266 or ESP32, you need to download two packages from Espressif website, support section, and here you have Flash download tools. That is the software that enables you to flash the new version of firmware in the memory of your ESP32. And the second package is the EAT interpreter firmware for your version of ESP32. In case of my board, I have ESP32C3, so I have downloaded the proper package for this. After this, you need to connect properly the ESP board to your computer. You do it with a USB port. And you need to also go into the documentation, and this documentation describes this connection. So you flash your board with USB connection that presents the download UART port, and the AT command uses the completely different serial port, UART1, that is visible at different pins. So to be able to connect and use AT commands, you need to use external USB to serial converter and connect the serial port to pins, in the case of ESP32C3, GPIO6 and GPIO7, and you need to look into this documentation and connect the pins to the proper GPIOs. After connecting your board with USB, you start Flash download tool, and at the beginning, this Flash download tool enables you to choose the type of your chip. So in my case, this is a ESP32C3 version. Work mode should be left develop and load mode UART. And after starting, we have the main screen of your software, and here you choose the version of this EAT interpreter firmware. You should choose the version factory. This is the complete content of flash memory, so it's much easier to download this version. You upload it into the flash memory at address 0. You need to pick up the proper COM port. The COM port you can find in the device manager. Here we have number COM5, so here you specify COM5 and you can start uploading. While the firmware is uploaded, you can prepare this other connection. Of course, you cannot disconnect anything from USB port, but you can start the software for connecting the AT interpreter. This software is named PuTTY, or it can be any other version of terminal program. As you can see, our memory has been flashed, so we can unplug the USB connection of the flashing firmware, and we can plug the USB to serial converter. As you can see, the number of COM port has changed because we have here different chip for this conversion. And after this, we need to start the terminal program that can be PuTTY. The original PuTTY software has one drawback. It doesn't allow to send the full enter, so 2 characters. It sends only 1 character enter that is not properly recognized by AT commands, AT-firmware. So you can use some other terminal program, or you can use the modified PuTTY CRLR version. Okay, so let's try if it works. We choose the COM10 as our COM port. The speed of transmission is 115200. And here in keyboard, we need to enable CRLF for proper recognition of our AT commands. While we open this port, we can write AT, and if we get any response like OK, it means that we properly flashed our firmware, and we can use AT commands to connect to Wi-Fi, to connect to Bluetooth, and also connect to MQTT, and use many other features of our ESP32 board with this commands.
After uploading AT firmware and connecting the module to the PC, an ESP8266 or ESP32 can be used as a modem with simple AT commands. It is possible to connect ESP32 to a PC with a TTL serial to USB adapter. Connection to any microcontroller with a serial interface doesn't need an adapter. The default serial port settings are baud rate 115200 bits per second, no parity, 8 bits in the data frame, and 1 stop bit. Notice that the serial port used for AT commands differs than the port for uploading the software. That's why we can't use the USB port available on the ESP board, and we need to use an additional TTL serial to USB adapter. We have to observe the pins used for the serial port. For example, in ESP32C3, the RX input is available on the GPIO6 and TX output on the GPIO7. Details of this and other versions of ESP system on chips can be found on Espressif website.